Okay, so we've been looking at sequences and series and patterns. And I told you at the beginning of the lesson that you should think about, like as we study, you should think about places in our real life where these sequences could be applied. But then today, before we start, I'm going to ask you, why do you think study sequences? Jeremiah, please mute. To mute you, there is down here, there are some things, there is mute, stop video, security. So you tap mute and then you'll be able to mute your microphone so that we don't hear the feedback or we don't hear the noise in the background. And then you can unmute when you have to speak, when you have to speak to the class or to me. Okay. So today morning, I want to ask you people, why do you think we study sequences? According to what we've covered so far, why do you think we study them? And according to what we've been doing, where do you think you would apply this knowledge? Because it's important to know where you apply the knowledge that you get from here. So in your own words, you can tell me where you think you're going to apply this knowledge of sequences and patterns. Where do you think we shall apply it in real life as a mathematician? Okay. Before I start choosing people to give me answers, for those that have issues with their microphones, you can just type your answer in the chat room. But when you need to use your microphone, you put up your hand and I choose you and you give me an answer. Okay, so Amira says when designing, I think she's talking about patterns. You need to have knowledge about patterns and flow when you're designing. She probably wants to be a designer. Yes, Marilyn?
In accounting, especially sequences, when you find that the money is still coming the same way, sometimes means that someone is laundering the money. When someone when you see that the money keeps staying in that same state and keeps coming, that exact amount, sometimes someone is laundering money.
Okay, thank you. Maysoon? Maysoon, unmute and give me your answer. Okay, I've given you enough time to tell me something, but you're not saying anything. I don't know why. But later on, okay, yes?
During farming.
Okay, in farming, you can use sequences and series and patterns in farming. Okay, so the other, I see there are no other hands, so I can add on some of my ideas. The other places are also in programming. Do you ever wonder about the fact that when you record a video yourself, I know people do, I know some of you even have TikTok accounts, you do videos and you send there. Some of you do videos on Snapchat and you record yourselves and put on your statuses. Sometimes you will find that when you are recording, let's say you are recording with a song in the background. Martha, can you please mute in case you're not saying anything? Thank you. So you'll find that when you're recording yourself, like the song is playing, let's say what song is playing. What songs do you people play in your videos?
Up. Jalebi baby.
One song that would Burigita.
Okay, Burigita. Okay, yes, let's say you're playing Jalebi baby in the. So you'll find that maybe you're trying to sing to the lyrics, but later on when you play that video, you'll find that the movement of your mouth shows that you are singing after the song. Like maybe they say Jalebi baby, and then the song is ahead of what you are doing. Or maybe you're recording yourself like taking steps and there is a lag. It looks like maybe you're walking in slow motion, yet when you are making the video, you are moving properly. So those people that do editing, people that do programming, or people that produce movies, they use knowledge from sequences and patterns to make sure that your mouth movement is matching with the lyrics, is matching with the sound, same as music producers. That is somewhere for people who want to do those things. You need to have knowledge about sequences. I'll explain how they do these things, because today's lesson is going to like give you an idea of how they actually put these things into real life. Because we've been dealing with numbers and sequences, so someone may wonder, but how do they put them into real life? And this lesson is going to show you how. Then another unique place I wanted to share. Okay, someone shared about accounting. Yes, you may wonder like how do the bosses or the CEOs or the COOs decide how people will get salaries, even if some people are more qualified than the others and some people join a bit later, how they decide what salary to give this one, or how those insurance people decide what percentage to cut. All those things have sequences. So of course, right now, we may not go into details of how these things are applied, but you should have an idea. One thing you should know about math is you apply it almost everywhere in your life. So today we are going to learn how to generate a sequence. Okay, most times those people that actually apply sequences in their work or in real life, what they do, they start with what they have. They start with what they have. What do we have? We have a video whereby, let's say Jeremiah is walking, but the footsteps are not matching the music. So they start with the problem, and then they generate a what? They generate a sequence that will help sync the movement of his feet with the music. Is the board blurry for everyone? Amira is asking. I think to her the board is blurry.
No, it's not.
Okay, then it might be Amira. Okay, so that means you have to know how to generate a sequence. You have to be able to like look at different figures and ask yourself, what sequence is this? What were they doing? And we've already been doing that, but sometimes it's not very, very obvious, and you have to study them for a longer time. Like you study a sequence for a longer time and you find out a pattern, you generate a formula, and then you say, I'm going to use this formula to be coming up with my sequences in this case. Now, for those that had already looked at this topic, had you gone this far? Did you look at how to generate a sequence?
I don't think so.
Okay.
No,
okay.
we had it.
Okay. So I'm going to be really very slow with this one because now it's new to everyone. Okay, so now usually we've been dealing with sequences. Let me put a simple sequence. Let's say maybe you 2, 5, 7, let me put 10, and then they tell you to find a number. Usually you just observe, you study, you ask yourself, what are they adding? What are they subtracting? What are they multiplying by? Jeremiah, please mute. Jeremiah, please mute. Okay, thank you.
I told you not giving an answer. Mute.
In case you're not sure about how to mute, it's down here. There is a microphone like thingy. Jeremiah, please unmute, distracting the class.
Unmuted.
Okay. If I'm tired of seeing the same hands, I want other people to contribute to this lesson. People like Elizabeth, people like Noreen. Yeah, I want to pick new people. Okay, I'm not sure what these people want to tell me, but let's find out. Yes, Rihanna.
Teacher, I just wanted to give the answer.
You wanted to give the next number?
Yeah.
Okay. I actually just forged this pattern, this sequence. I didn't know it had the pattern. Okay, what's the next number?
It's 12.
It's 12. Yeah? What were you doing?
Yeah. Since 2 plus 3 is 5, 5 plus 2 is 7. 7, we add plus 2, plus 3, plus 3, plus 2, plus 3,
Okay. Okay.
plus 2.
Okay. Okay, thank you. So we have been dealing with search. They give you a sequence and you find the next number. Now someone may ask you, how did they come up with this sequence? How did they start with 2 and then go to 5? So that is what we are going to look at today. So before we go into details, I'm going to just go through the terms I'm going to be using, like the ones I'm going to be using so that they don't confuse you. So when you have a sequence, usually sequences are continuous. They don't come to an end, they are continuous. So this sequence actually continues, just that we may stop somewhere and ask you for the next one number or the next 2 numbers, but this sequence actually continues till. But now, when you're looking at the numbers in the sequences, you call them terms. For example, in this case, 2 is our first term. Okay, it's the same spelling as the normal terms that you people know, first term, second term, third term. Then our 5 is the second term, our 7 is the third term, our 10 is the 4th term. So whenever you look at any sequence, the first numeral or the first digit they write will be the first term, then the second term, then the third term, then the 4th, up to wherever you want to reach. So when people are coming up with sequences, they actually follow terms. They don't exactly follow this, they follow terms, and then they use a formula to find out which number will be my first term, which number will be my second term, which number will be my third term, and so on and so forth. Because remember, initially when you start with something blank. You don't have a sequence, you don't have a pattern, you don't have anything. But then they want you to generate a sequence that makes sense, a sequence that has a pattern. Is my network bad? I'm on and off.
No, it's not.
No, it's okay. It's okay.
Okay, I think some people are having network issues. I'm very sorry about that. I hope you don't get lost somewhere because this is very important. It's very important for your activity of integration, and I need you guys to understand it properly. So usually you know that a sequence has a flow, there are digits that follow each other. So that is all you know. So they will tell you generate a sequence. Maybe they will tell you generate a sequence to show maybe how many cars, how many taxis pass by. Which road is this? It's Ginger Road. How many taxis pass by Ginger Road? If you can't see, what do we do when she can't see? Hey, why can't you see? I have what? I have spotlighted myself for everyone to see me. Okay, let me remove spotlight and then put myself again, just in case. Maybe to work for people. Okay. I hope now people can see me. If they can't see me, then it's definitely a network issue. Okay. Yes, so that is what we are going to try to do today. We are going to try to come up with, to generate sequences. But before we do that, we are going to use sequences we already know, and we try to predict what the people that came up with those sequences could have been following. What do I mean? Let's say you have a sequence like this. You have maybe 5, then you have 10, then you have 15, then you have 20, then you have 25, and so forth. This time, I'm not asking number. I'm asking you to think about it. Tell me before I show you maybe how like you can following to come up with this sequence. Some people still can't see that, but I think it's a network issue. What they've told you, turning off your and coming back. Yes, Aliyah.
They kept adding 5.
Okay, Aliyah says they kept adding 5. Okay, let's see. Is it true? Yes, it makes sense. They kept adding 5. Is that what everyone is seeing? They kept adding
Yes,
5.
teacher.
Okay,
Yes,
okay. Okay, thank you. It's good I started with this one, which everyone can see properly. So now I can explain. Now, you people are saying they kept adding 5 because they actually gave you the first term. But remember, this person had nothing. This person had a blank page. They didn't even know that my first term was 5, my second term was 10, that they had a blank page. So they were starting from the bottom line, from the beginning. So they are trying to come up with that sequence. So how these people do it, or how you will be doing it, you actually follow terms. You don't follow the sequence itself because you don't have the sequence yet. You follow terms. What do we know? We know that our sequence will always have a first term, a second term, a third term, a fourth term. So in this case, we have 1, 2, 3, 4, 5 terms. So I'm going to draw. Sorry, I'm going to write 1, 2 up to 5. And then people will tell me which one is my first term, which one is my second term, and which one is my third and fourth and fifth. Okay, so you have your, which one is the first term in my sequence?
5.
5.
5. Okay. Which one is my second?
10.
10.
15.
15.
20.
25.
25.
Then 25. So this is my
25.
sequence. But when we are starting, like we are trying to create a sequence, this is all we have. We just know that we shall have a first term, a second term, a third term, because remember sequences are continuous. So you don't skip, you don't come from the first to the fifth, you come from the first to the second. So this is all we know. Our first term is 1, our second term is 2, our third term is 3, our fourth term is 4, like that. So this is what we actually use to find out the formula they use to generate the sequence. So you ask yourself, if my first term, my number 1 term is 5, what did I do to this 1 to get 5? Let us start from there. You ask yourself, if, like, what did I do to that 1 to what? To get the 5. I need like
what do you mean?
I need, pardon?
What do you mean by like what did you do to the 1?
I think she means that. What did you do to that?
What did she do to the first term?
The one to the first term to get that 5. According to me, I think teacher added 4 to get the 5.
Okay. So okay, someone says they think I added 4 to get the 5. Now that is true. That is true because when you say 1 plus 4, you get 5. Remember, we do not know what this person followed to get the sequence. We are trying to figure it out. So really any pattern.
I think you got 5, then you got 5 minus 1, then you got the 4. Then you just said 1 plus 4 to prove that it was really giving you an answer of 5.
Okay, thank you, Maysoon.
1 by 5.
Aliyah says I multiplied 1 by 5. I think the other people have similar answers except Aliyah. Aliyah says she multiplied 1 by 5. By the way, this is how you do it. Like, this is where you start. Let me try to get some answers from the what? From the chat room. Okay, even Husna says I multiplied 1 by 5. That is true, because when you multiply 1 by 5, you get 5. When you add 1 to 4, you get 5. Then you ask yourself, if I follow that pattern, will it give me the same for the second term? So our first term, you're saying you added 4 to 1 to get 5. So if you add 4 to 2, do you get 10? No. So realize that the pattern that you are coming up with does not apply on your second term, your third term, and your fourth. Then you eliminate that one. If I see it's try and error. Agatha, please mute. You are studying while babysitting. Over that is you, and I think it's a baby. That might even be Agatha herself.
No, teacher, it's not me.
Okay. So let's try and see if this works. So when you multiply 1 by 5, 1 times 5, let me write it here. 1 times 5, you get 10. When you multiply 2 times 5, do you get 10?
Yes.
Yes, you do.
The first and the second term. When you multiply 3 by 5, do you get 15?
Yes.
You do.
You have to check. Yes. You have to make sure it applies on all the terms. So I can see it applies on also the fourth term and also on the fifth term. Then that means that the pattern this person was using is multiplying by 5. So to get the first term, this person multiplied 1 by 5 to get the 5. To get the second term, multiplied 2 by 5 to get the 10, like that, and so on and so forth. Is that part clear?
Yes.
Yes, teacher.
Okay.
Yes.
Teacher. You can ask questions at any point. You can ask questions at any point.
Excuse me, teacher, if you say like she kept on adding +5.
She kept on adding +5. But remember, we are starting with 1 because 1 is
cannot give you 10.
Let me answer. Okay, I forgot the person who has asked, but let me answer her. Because you people have to keep in mind that you actually don't have these things yet. You're trying to come up with the sequence. So if you're adding 5, that means you're saying 1 plus 5 to get 6, 2 plus 5 to get 7, 3 plus 5 to get 8, 4 plus 5 to get 9, 5 plus 5 to get 10. And that is not the sequence. Have you seen it?
So this means that we are multiplying the number in place of the first term by all the terms.
These are terms, these are the numbers of the sequences.
Yes.
Yes. So like when you're determining the sequence, you use terms. Because okay, when I give an exercise, I'll be giving you the sequences and ask you to find the pattern. So of course you will know the sequence. But what we want you to be able to do is to be able to go out there as a mathematician and you can look at information. Like I've told you, you should be able to find a sequence that shows how many cars pass by this Navisosa slope on that Ginger Road. So what you will do, you as Faith, you as Amira, you will go with a notebook and a pen. You say how many taxis are passing at 7. Let's say you start at 7. At 7, there are 6. At 8, there are this. By 9, then at the end of the day, you come and you look at the number of cars. You're like, now looking at these numbers, what sequence or what pattern can I generate from here? So you actually get your own sequence and you get your own formula. Just that here we've given you a sequence So you know that my first term is 5, my second term is 10, my third term is 15. But when you are generating a sequence, you use terms. Your first term is 1, like term 1 is 1, term 2 is 2, like that. So whichever formula you use, you'll be using the terms, not the sequences. Yes, Aliyah?
Can the terms change? Like let's
No,
say
no, no.
let's say my first term, okay. The terms, like let's say term, like okay, like instead of having term 1, I have term 2, then 4, like term 4, then term 6, then term 8. Like can the terms be in a different order? Or they have to be 1, 2, 3, 4, 5.
Yeah, so is this order? Why? Because you people remember at the start we defined what a sequence is. And the main points were it is continuous. It is continuous. Continuity means there is no dot. If they said that woman spoke continuously, it means that person didn't have a full stop, the person didn't even cough, the person, like you do it continuously, you don't skip, so when you're writing term, you start from 1, you keep 2, 3, 4, 5, you don't skip any number, you don't change the order, it is a continuous flow. Yes, Amira?
Teacher, I've been having network issues, but you guys are saying term. What is term? I'm not getting.
When you have a sequence, when you have your sequence, let me even remove this sequence so that we don't keep looking at the same sequence. It will bore us, not so. Let me put a different sequence. We try to, okay, let me put this one. We have 11, we have 21, we have 31, 41, 51, 61, and so on and so forth. So when you have a sequence, your sequence has started from 11. If your sequence starts from 11, that means 11 is your first term. That's why we've been having a table like this, and under 1 you put 11, under 2 you put 21 because 21 is your second term, under 3 you put 31 because 31 is your third term, and so on and so forth. So Aliyah asked, can the order change? The order cannot change because a sequence is supposed to be continuous. It's supposed to be continuous.
Teacher, I think that sequence is wrong.
Okay, it could be wrong. We shall find out. We are going to try and see if we can find a flow. Because remember our pattern is a sequence is supposed to have a flow. This one is 61. Okay, so this time we have 6 terms. Okay, let me first see this question. Excuse me, teacher, using the table, can't you add multiples of 4, like 1 plus 4 is equal to 5, 2 plus 8 is equal to 10. Oh, yes, that is also correct, Alicia. Yes, it's also correct as long as you are adding those multiples of 4 to the terms. The way you've done it, you've said 4 plus 1, 8 plus 2, then you go to 12 plus 3, like that. So that would also work. I hope you know you could notice even when we're just doing sequences, you can have like several ways of getting the flow to the sequence. So that is also correct. Okay. So someone was saying the sequence is not correct. So let's see. Let's mark and see. You see the good thing with this syllabus, you can even tell the teacher you are wrong, and you give the teacher your reasons. I don't know what your reasons are. Okay, you first tell me your reason.
For me, it's right.
So my reason is because we are learning terms here and the number in the sequences. What the first term is 11. When I multiplied 11 times the second term is 22, and yet you wrote 21. When I multiplied 11 by 3, I got 33. When I multiplied 11 by 4, I got 44. When I multiplied it by 5, I got 55, and by 6, 66. That's why I think you're wrong.
Teacher.
Okay. Does someone want to help me explain to her what the issue could be, or does someone want to back up?
I think We are not supposed to only multiply, the other ways.
Okay. Okay, Amira, I said it's not just multiplication. Does anyone else want to add on anything before I say?
Okay, teacher, I would like to say, okay, forgetting about that, okay, not forgetting, sorry. Like if you use the other first method of 11, for example, 11 plus, then it gives you the
gives
answer.
you
But
a
then when
pattern.
you use the term one, okay, I have not yet found the answer. I'm not really sure. Yes, it gives you a pattern. But then when you use the term method, it like, okay, for me, when I've tried it, it does not come out.
Okay, I get that argument. You can easily tell what the next number here will be, what the next number could be, but you cannot generate the sequence yourself. Okay, that is
Yes.
Aliyah, your hand is up.
No, it was the same thing as my soul. Like I was going to say the same thing. Like you can tell the sequence but using the terms.
Yeah, that is true. The sequence has a flow, like because you can just see from like basically it's like they are okay. Let me not even say it. What's the pattern they are following? If people you tell me, people have said that it has a pattern.
10.
They are adding
10.
From 11, they just keep adding 10. So that means here the second one would be, the next number would be 61 plus 10. So our sequence has a flow, it has a pattern. Okay, now the part you percent you don't know is the part we are supposed to be learning. So we are going to learn it together. Okay. So let me first clarify the confusion of the first person that asked. I'm sorry, I've forgotten who had asked. The person who said the sequence is wrong. When you use what you are using, yes, the sequence is wrong, but now the issue is that's not how we are determining the flow of the sequence. When you're determining the flow of the sequence, you use the terms. You use these upper things. You use 1, 2, 3, 4, 5, 6. You use these upper things to get these lower things. So when you're multiplying, what you're multiplying with anything, you don't multiply the 11, you multiply the 1. So you say, when I get my first term, I multiplied for 1 by something. You get my second term, I multiplied 2 by something, or I added something to 2. You don't use the 11 the same way you had told me 11 times 2 is 22, 11 times 3 is 33. You don't use this 11, you use this 1, you use that term, the value of the term, because you do not have this 11. You are trying to find out, how did I come from my 1 to my 11? So you don't use that 11 because at the beginning you don't even have it. So you are trying to find out, how did I come from 1 to 11? Because 11 is your first term, but at the beginning you didn't know that 11 is your first term. So how did you come up? How did you come from 1
to 1?
Excuse me,
okay,
teacher.
Yes, Grace. Was it Grace? Grace, you asked the question.
I think your network is poor. Yeah. Teacher, I think your network is poor. Calls the staff.
No, teacher, it's fine.
It's not. It's all right.
Okay, now
To me it is.
okay, to you it is. Okay, this is what we usually do. Yes, Agatha.
I'm not understanding.
Okay, so it's okay. We are going to do as many examples as possible until people understand.
Okay.
For those people that are having network issues, the truth is my network is okay. So this is what we'll do. Try to follow as much as you can. Then next time, if you can change the network, change it. If you're using Leica, don't use Leica. Leica has issues or free sale. You can use something more stable according to where you live. But now, in order to get this information, you just go to the e-learning platform. Then you go to recorded lessons. These lessons are recorded and uploaded, so you can go there and watch the whole lesson. Because since my network is okay, if you watch the recorded lesson, it will have a flow. I won't be freezing. I won't be the sound won't be on and off, so you will be able to follow. Okay?
Okay, thank you, teacher.
So we are trying to think about how did you come from 1 to 11. Someone has told me you multiply 1 by 11. Then someone had told me you add 10. So you say 1 plus 10, yes. Both of them actually go to 11. Is there any other way we can come from 1 to 11?
Yeah. No.
No, there is
Okay.
no.
Abella?
Eleven plus 0.
11 plus 0. I hope you can see here. I can also add mine. But you have to be like super creative. I can add mine, which is actually similar to these ones. I can say, they said 1 times 10 plus 1. Do you realize that that is the same as this one actually? But that one is, I've just added birungo. Yeah? I've added birungo because this is the same as 10 here. Yeah. So you can also do something like that. Someone has said 12 minus 1. So we can have 12 minus 1. What you should look out for 1, you have to make sure you use 1. So you can see here we have 1, here we have 1, here we have, oh, that means Isabella's thing goes out because we've not used 1 anywhere. You're supposed to be able to use 1. Here we have 1, here, even here we have
Valeria. 11 divided by 1.
11 divided by
1.
11.
Eh? 11. Teacher?
As long as you're using 1, we are going to test all these we see. Yes, Agatha?
11 divided by 1.
Yeah, I've written it. Okay, let's test each one of them one by one. You use this one to see all the possible ways this sequence could have come about. After that, you try to see if any of these patterns applies to. You see if any of these patterns applies to all the terms. Okay. Okay. Okay, some people are actually already proving the terms. People are already proving the terms. So let's do that. Let's start with this one, 1 times 11. So when you multiply 1 by 11, you get 11. When you multiply 2 by 11, you get what?
22.
22.
But here we have 1. So let's first remove that one because it only works for the first term. Okay, let's go to this one, 1 plus 10. When you say 1 plus 10, it's true, you get 11. If you say 2 plus 10, you get 21.
No,
you get 12.
Yes, so we also remove that one. We go to 11 out of 1. Okay? That means you are multiplying 11 by that term. So 11 out of 1 is 1. Is 11 out of 221?
No.
No. We also remove that one. Let's check mine. We have 1 times 10 plus 1. So 1 times 10 plus 1 is 11.
Yes.
And then the second term where there is 1 with 2 times 10
plus 1.
Plus 1
21. Yeah.
21.
Does it work for the third?
Yes.
Yes.
Does it work for the fourth?
Yes.
Yes.
Yes, it works for all.
It works for all.
Okay. Then you think that the pattern they are using is okay, instead of writing, write n and plus 1. Why am I using n? I'm using n to indicate
Represent
these terms,
the term. Yes.
the terms to show that for the first term, I put n is equal to 1. For the second term, I put n is equal to 2. For the third term, I put n is equal to 3. For the fourth, is that okay?
Yes.
Okay, then what is n times 10?
1 times 10. Presenting 10 n plus 1.
Yeah. When you multiply any number by an unknown, you just have something like that. For example, if you have 2 times m, you have 2m. If you have maybe 9 times x, you have 9x. That's what I've done here. I've said n times 10, I have 10n plus 1. Now this thing is this one is what we call the formula. So this is the formula this person was using to generate the sequence.
Sequence.
Yes, so this person used this formula and generated a sequence. And this sequence could have gone on until further notice. Even if this person was starting from, let's say, 41 here, and maybe they were going on, this formula would have worked. Have you understood that?
Yes.
Okay, if you have any questions,
mine is actually about 2 times m. What if it's like m times m?
You get m squared.
Yes, you get m squared. But that is algebra. You people study it in S2.
We studied it in P3.
What about if you use 1 times 11 minus 1 for the pattern? Would it work?
Okay, let's check it out. Okay, instead of writing 1, let's write n. Okay, let's say n times 11, then minus 1. That's what you were saying.
Yes.
Okay,
I got it from that chat. Somebody was asking.
Yes. Auntie Munange.
Was it Husna N? Somebody was.
Okay, let's check it out and see. If your n is 1, you have 1 times 11, which is 11. Minus 1 is 10. And our first term is 11, so this one wouldn't work. Let's say plus, right? It wouldn't work.
Teacher, why would it n times 11 minus 1 work? Imagine you put 2 times 11 minus 1.
Yeah, but then our first term is 11.
It does not add up to 11 when you're using the first.
Okay.
You've seen it, eh? Our first term will be 10.
Yes.
Yeah, and remember, of course, if it doesn't work for the first term, then actually, if it doesn't work for any of the terms, then we can't use it. But you see where I'm going.
Yes, teacher.
Yes, teacher.
So now I think people already see how to generate sequences. People use formulas. People use formulas like this to generate these sequences. But you have to know both. You have to be able to use the formula to generate the sequence and to look at the sequence and generate the formula. So I'm going to put a small exercise here. What sequence do you generate? One of our last lessons about series, we shall look at a video that shows you how they apply all these things. You know, like what sequence do you generate? Now, one thing you should know is that each formula is very specific to its sequence. So it's not possible to find one formula giving you many sequences, but it's possible to get many formulas from one sequence. Do you get my point?
I beg your pardon?
It is a formula can only give you one sequence. But if you look at a sequence, you can get several formulas from it. Okay, so I want people to generate the sequences from here. Do you need a clue?
Yes, we need a clue. Yes.
Yes, teacher.
What you should know is that this n stands for the terms. The terms. Your n is equal to 1, 2, 3, 4, 5. It's you who is going to decide where your sequence will end. You can decide to take your sequence up to only the 5th term or up to the 10th term. It's up to you. As long as after you reach maybe the 5th term, you put the dots to show that it actually continues. So to get your first term, where there is n, you put 1. To get the second term, where there is n, you put 2, like that, and so on and so forth. I've given you for a clue, so let me wait for my sequence. And I want someone who has not yet put up their hand. Janet, tell me what sequence do I get here?
Shall you get 4, 9, 14?
You want to stop
and
there?
19. 19.
Okay, so when you choose to stop here, you put dash, dash, dash to show that this sequence actually goes on, because you can take that n even up to 1 million. It will keep on moving even up to 10 million. You can say 5 times 10 million minus 1. That is also part of that sequence. Amira, yes? Are you giving a second sequence?
I got 8, 14. 20, 26.
Okay. Did anyone get a different answer? Or does anyone want us to go through any of the numbers? How are you getting the sequence? I don't understand. Okay. Babire Shifra.
Excuse me, teacher. I was asking, do we all generate our own sequences? Because on part A, we see 5n minus 1. Do we put n as any number of our choice?
You use this flow. For the first term, you put n is equal to 1. For the second term, you put n is equal to 2. For the third term, you put n is equal to 3. The only difference might be on where you stop. Some people may only stop on terms, some people may go up to the 8th term, some people may give me 5 terms. That is what differs. But these first terms will be the same one because you're using the same formula. So you put the, I'm going to use this chance to also explain for those people that have not understood how we are actually getting this. I'm seeing some people in the chat have said they've not understood how we are getting the sequences. So I'm using this chance to also explain as I answer a question. So to get this first term, where there is n, you put it. So it becomes 5, can you see here? Yes, you can. It becomes 5 times 1 into brackets minus 1. I put this into brackets because I want to first deal with it here. So 5 times 1, you have 5 minus 1, which is 4. So you can write here 4. Then you go to find your second term. Now your n changes to 2. So instead you have 5 times 2 minus 1. 5 times 2 is 5 times 2 is 10. 10 minus 1 is 9. So your second one is 9. So to get the third one, where there is 3. 5 times 3 is 15. 15 minus 1 is 14. So that is how these people are getting these sequences. Your n, yeah? Your a. This is always your n. Your n is always that 1, 2, 3, 4, 5, 6. Where you stop it up to you, but it will always start like that. So you can stop. Okay, don't give me a short sequence. Don't stop on 14. You give at least like 4 or 5 numbers. Okay. Yes, very Shifra.
Thank you.
Okay. Amira, your hand is up.
Okay.
Teacher, I forgot to ask.
Oh, okay. What about Alicia? Now you see Joeria. Joeria's sequence, for her, she even went up to 29. Then this one had stopped on 19, yeah, it stopped on 14. So that is where the difference can come in, where you stop, but the beginning will be the same. Yes, Alicia?
Teacher, I did not understand how you got the sequences in part B.
Oh, okay. Who remembers that? Can I remove this?
Yes. Part B was 6n plus 2.
6n plus 2.
Plus 2.
So Alicia is the sorry about that.
I know it is too much.
That the network is
Okay, so I've told you your one is always those counting now, your n is always those counting numbers 1, 2, 3, 4, up to wherever you want to stop. So this time let us stop on the 7th term. Eh? So we have 1, 2, 3, 4, 5, 6, 7. So this is the formula we are using. Where there is n, we shall put 1 for the first term. So let's first find the first term. 6 times 1, then plus 2. So 6 times 1 is
6.
So you have 6 plus 2. 6 plus 2 is
8.
8.
Our first term is 8. So we try to use the formula to get the second term. So where there is n, we put 2 now. So it is 6 times 2 plus 2. What is 6 times
14.
14?
6 times 2 is 12. Plus 2 is 14.
12. Okay. Okay, 12 plus 2, which is 14.
14.
I'm answering your question. Eh? That's how they got the ones for B. We are going to go up to the 7th term. So what is the 3rd term?
6 times 3 plus 2.
6 times 3 plus 2.
That is
6 times 3 is
20.
18.
Yes, teacher, it's correct.
Another person gives me the 5th term, the 6th. I hope the person who had asked has now got it.
Yes.
Yes, teacher,
Okay.
thank you.
Okay. Hayupo, give me these terms, then I give you more numbers. You try out and you can stop there. We are going to take our time with this one. Because
Teacher,
it's the one. Yes.
are we adding on the for part B the sequences?
Yes, I want
we are. For the 4th term is 26, then the 5th term is 32.
The 6th is 38. The 6th is 38. Then the 7th is 44. 44.
Yes. You write as a sequence. You write 8, 14, 20, 26, 32, 38, 44, dash, to show the person that we are going on forever. Okay. Now in the next lesson we shall use we shall learn the use of these formulas. Why do we even need these formulas? You can realize that you can even just look at a sequence and find out the patterns. So next time we shall find out why do we need these formulas? Because these formulas, some of them you take time to find them, but now why go through that struggle? We shall find out in the next what? The next lesson. For now, let us master how to use these formulas before we can find out why they are here. Okay, so here you put up your hand, you give me your whole sequence up to where you stopped. When we are doing these things on the board, you know they look simple. Please try out in your book. You see, math is very confusing. When the teacher is doing on the board, things look easy. Then later, when you try out, things start confusing you. So you try now. If you get confused, you ask. If you wait and try out when you are alone, okay, I think we can decide. Let us agree to give at least five numbers of the sequence. So you can give 5, you can give 6, you can give 100. So you put up your hand when you prepare the whole sequence, and then you will share with me the sequence.
I've done part C.
Part C, okay.
I did 6 terms. So we have 9, 18, 27, 36, 45, 54.
Okay, if you disagree with the sequence, you say, teacher, that girl has lied. Yes, Amira?
I've done part E.
Part E, okay.
And it's 6. Teacher, can you hear me?
Yes, you can.
I got 6, 8, 10, 12, 14. Yes, there.
Yes, Alicia?
Teacher, I've done part D.
Part D. Okay, give me your sequence.
12, 24, 24, 36, 48, 60.
One, two, three, four, five. Those are enough. Yes, Janet.
Teacher, part F.
Part F.
2, 2, 5, 5, 8, 11, 14, 11, 14, 17.
That's the last one?
Yes.
Okay. Who wants to give me the last one?
Teacher, I cannot see it very clearly. Like I can only see some very little part, the very last one. And
-2. That is part what? Part G. Yeah? Part G is 3n minus 2. 3n minus 2. Agatha, I see you've unmuted. Do you want to give me part G?
No, teacher. The blackboard is far. It shows when it's clear. Another time it shows when it's not clear. It's confusing, but I'm understanding.
Okay, it's good you're understanding. Later on, you can go to the website and you watch the whole lesson. Yeah? You'll be there.
Okay, madam. Yes.
There are so many Babires in the class. Yet I've only heard from Babire Shifra, Babire Mariam, Babire Eliana. People should participate also.
Oh, yeah.
Okay, whenever you're ready. Okay, Mason.
3n minus 2, I got 1. I got 4, 1, 4, 7, 10, 13, 16. Those are all I got.
Okay. Please don't forget to add these things to show that you can actually go on, because you people even know that you can actually go on and add in more numbers. Okay. Does any of you have any question about what we've looked at today? Okay, we have not looked properly into how to get the formula from the sequence, so we shall elaborate on that next lesson. But at least if you're to take anything from today's lesson, take this, how to use the formula. Because now this is where you actually start from the formula and then you generate your sequence. Are there any questions about today's lesson? Yeah, you should ask me these questions, because if you don't ask them, I'm going to ask them later on in future. Yes, I think it was Manuela. Manuela, your hand is up. Let me see. Did I read the name right?
Yeah.
Yes, Emanuela. Okay. Yes, Emanuela.
Teacher, my network is poor. What does the N stand for?
The N stands for the term. The N stands for the term. So basically your N, your first N is 1, your second N is 2, your third N is 3. So basically, by the way, these terms even show position. Like your first N is the number in the first position of your sequence. Your second N, second position. Third N, third position. So these terms show position, they also show terms. Terms, okay, terms is the mathematical word that we use to call those things. But in normal English, it's position. So for the first position, you have your N is 1. For the second position, your N is 2. For the third position, your N is 3. Thank you for asking. People should always ask. People should always ask. It's the only way I can know that people are following. Okay, so I guess people have got it. We have used up all the time. We have used up all the time. Yes, Rania.
Excuse me, teacher.
Yes, Rania.
Excuse me, teacher. My network is also poor. I'm asking, do we like use the same sequence, or we can use different numbers on one number?
You're saying N. Yes, your N is always 1, 2, 3, 4, 5, 6, up to wherever you want to stop. Your N is always like that. You can't use different ones. I hope I've answered your question.
No, teacher. Teacher.
Yes.
I'm saying like on part C, like
part C.
It's 9:18. Teacher.
27. So you're asking if someone can come up with a different sequence but using the same formula. The network is really bad. Which network do you people use?
Yes. Pardon?
Rania, your microphone shows that you're speaking, but I can't hear anything. I don't know if other people are hearing you. People are sitting on branches of trees. Kale. Rania.
Teacher.
Can you hear me? Yes.
So I was asking, can we like use different numbers but using the same formula?
For this n, you always use 1, 2, 3, 4, 5 up to wherever you want to stop. Then each formula, like one formula will always give you one sequence. Like if you're to fill in those numbers, 1, 2, 3 up to wherever, it will give you the same sequence route. So you can't use whichever numbers you choose. You can't say, let me just put a 9, then I put a 2. No, you put those ones in order. Because we are generating the sequence, so we want to start from the first term. Of course, later on, when you are programmers, when you are designers, you can start from wherever you want, depending on what you want to do or what problem you want to solve. But for now, we want to generate from the first term. That's why we start from 1, we go to 2, we go to 3 in that order. Okay, let's call it a day. I'm going to load an exercise. So you should go to the website and try out the assignment over the weekend and you hand in.
Teacher, where is the exercise?
Okay.
Teacher, wait, teacher, where is the exercise? Like, where is the activity that you're talking about?
People are not tired, Banang.
We just want to like, we don't want.
You're the one who has said that there is an activity, but you haven't given it to us. Is it there or not?
We just don't want to be idle.
No, teacher, I'm asking. I was just asking if it's there.
So you are willing to study up to 2 because you don't want to be idle.
No, teacher, I was asking. I was just asking.
Teacher, let's not study up to 2. Some of us have other business to do.
Some people have
then I thought since it was extended to 12 to start from 11:30, I thought it would end at 1.
At 1, yeah?
Yes.
No, we were supposed to end at 12:30. Actually, even before that. People want to be idle. People want to go and start watching their Korean things. You see these days,
Teacher, not being idle. We wake up early in the morning. Our sleep right now, I'm dozing. Seriously.
Yeah, teacher.
You put on the video and we see someone dozing.
Okay.
This is how you look like when you're sleeping.
For those asking about the work, you'll find it on the website. Like you'll find it there already. So for you,